Hi everyone. Today we from Group 7 are going to be presenting our project which is titled Chemical Product Device Home Dehumidifier. Our group members are Ten Mun Chong, Hazika, Nadia and myself Yurtik. Before we begin, here is the flow of our presentation today where we'll start from our introduction and we will end with our references. So basically, a multinational company named AAM is looking to have a large investment in the development of a sustainable chemical product in our country. Hence, our startup company has been invited to propose the business proposal and design work of a chemical product. It is also noteworthy that sustainability is the theme in the design of our chemical product. Being citizens of Malaysia, we know that our country is renowned for its humidity. However, what many people don't know is that the monthly average humidity is between 10 to 90%, whereas the standard upper limits for normal indoor relative humidity is in the range of 60 to 80%. Dust mites, mold, and mildew are three of the most frequent allergens that thrive in moist and humid environments. Thus, the product that we will be proposing is the home dehumidifier. The need of a dehumidifier is absolutely necessary considering all the effects of high humidity in our surroundings.
Now, I will present the literature review part. Over the years, the demand for dehumidifiers has increased rapidly and the market for dehumidifiers become competitive. In 2021, the global dehumidifier market size was predicted as $2.91 billion and anticipated to increase at a compound growth rate (CAGR) of 6.8% from 2022 to 2030. Next is the market survey. There are two aspects which are environmental and safety and customer needs. For environmental and safety, the dehumidifier existing in the market consumes much electricity to be operated under normal conditions. An eco-friendly dehumidifier should be designed in which consumes less energy by using eco-friendly refrigerants. This kind of refrigerant does not contribute to ozone depletion and also makes a dehumidifier more reliable, quieter, as well as less vulnerable to wear and tear. On the other hand, for customer needs, the main need for the dehumidifier is to remove excess moisture in the surrounding air content in the room. This is because moisture air is the ideal environment for mold to grow, and a dehumidifier can remove the excess moisture and indirectly inhibit the growth of the mold. Next, excellent air quality is the aspect that customers are looking at. A dehumidifier should be able to remove dust, dirt, pollutant, and toxic gases. Excessive humidity can result in poor air quality, and an excellent dehumidifier should help to maintain the humidity level in the room. Lastly, a dehumidifier should be designed to have more mobile capabilities and in a small size, especially for long-term use. A dehumidifier that comes with a caster is convenient to use on a daily basis and allows the customer to move from one area to another area. Next, I will present the house quality of the dehumidifier. This is the list of customer preferences on the home dehumidifiers in Malaysia. All the customers' preferences will be further improved according to the technical requirements to obtain the optimal customer satisfaction. Furthermore, three competitors of dehumidifiers from different brands have been chosen, which are Media Competitor A, Honeywell Home Competitor B, and Hygiene Competitor C. And what's showing here, our product is able to remove toxic gases and do better than other products. Next is the business model schema of our dehumidifier. This VMC visualizes all the components needed to launch a business. The key partners in designing this dehumidifier will be the equipment manufacturers. Moving on to the key activities, R&D is a vital task in our company as we will constantly look for ways to innovate and improve the performance of our product. Next, in conjunction with our team of sustainability, the value proposition of our dehumidifier will be low energy consumption, green technology, and low global warming potential. We also promise to deliver excellent performance, production of clean or cool air, and control humidity while allowing our dehumidifier to be easily handled. We would also like to maintain a healthy and two-way relationship with our customers by providing them something in return for trusting our product and services. For example, we will give them the flexibility to make their payments through cash or card. As our dehumidifier is targeted for homes, our main customer segment includes land properties, apartments, flats, and condominium. Besides, the dehumidifier can be also used in a small to medium-sized office. Next, the key people who will help us deliver and grow this product are trained and experienced experts. Moreover, the channels that we'll be using to allow the product to reach our customer are through the retailers such as Setk. The cost structure is an important aspect in our product development as we need to consider all the possible expenses for the development of our product. Hence, this expenditure includes equipment and manufacturing costs, wage of our product, rent of our prototype. Lastly, our revenue stream from the launch of our product will be where mainly the skill of our products. We will be placing our main focus on selling as many products as we can, but at the same time, we will look at to expand our revenue stream through the maintenance and consultancy services.
Now for the product design, step 1 is the desired product performance.
For specified product performance, For this dehumidifier, moisture will be removed from 0.0215 to 0.014 kg water over kg dry air, where in this compressor, it reduces to 0.016 first before entering desiccant. The total power must be below 500 watt in order to achieve sustainability as low energy consumption. The enthalpy change and internal loop moisture removal in desiccant are also specified.
Okay, next for step 2 is identify the key ingredient and configuration. We have proposed three types of dehumidifier. Firstly is the compressor type dehumidifier. In this type of dehumidifier, we are planning to include the operation of HEPA filter, which will help in removing the dust and bacteria in the air before further removing of moisture. As can be seen in this figure that the cooler will be placed after the filter to ensure the condensation of air below the dew point temperature. Next, the air with the less amount of moisture will pass through the operation, which is the heat releaser, to heat up the temperature of air and release the warm air to the surrounding. However, the remaining moisture inside the air will be maintained during this heating stage. The next suggestion is the desiccant type dehumidifier. For this type, the desiccant wheel will be used to remove the moisture in the air by applying the heat transfer principle in order to maintain the temperature between the heat exchanger, desiccant wheel and heater. The common desiccant used in the dehumidifier is the silica gel. On the last suggestion is the hybrid type dehumidifier, whereby both compressor and desiccant type will be applied into one dehumidifier system. The position of each unit operation inside the dehumidifier is shown in this figure. Among all these three types of dehumidifier, we have agreed to choose this hybrid type as the best option. Next, for the step 3, we have to identify the phenomena involved in the dehumidifier. The first phenomena is the filtration. The HEPA type air filter will be used in this dehumidifier because it is able to capture the smallest particle size such as allergens, pollens, germs and many more. As you can see on this figure that each of layer in this HEPA filter consists of different diameter of the small holes. Hence, as the air passes through each layer of HEPA filter, it will increase the efficiency to capture the unwanted particles in the air. Next is the compressor type dehumidifier. It is the process where the humid air will be cooled down below the dew point temperature to ensure the water in the air condense and the removal of moisture. Then, the heat releaser will heat up the air back to the ambient temperature but maintaining the same moisture level inside the air. In addition, the most important part in the dehumidifier is the vapor compression refrigerant cycle, which consists of compressor, condenser, expansion valve and evaporator. The refrigerant is compressed to a high pressure and high temperature by the compressor, which is typically powered by an electric motor producing the work. The heat transfer will occur inside the cycle together with the increment and reduction of pressure at a certain unit. For the desiccant dehumidifier, it can be seen that this desiccant wheel has the ability to absorb water molecules from the process of airflow and continuously restore. The motor of desiccant wheel will be constantly rotated for the adsorption process. The reactivation air is heated after passing through the purge sector, which causes the relative humidity to drop to the extremely low level. After that, it is run through the rotor regeneration zone. The water vapor and desiccant molecular bond can be broken by the air, high temperature and low relative humidity. A warm, humid airflow is created as the moisture is added to the air, and this airflow is subsequently fanned outside the desiccant dehumidifier.
The last step is to use mathematical model to obtain desired product performance. Here, we will obtain suitable temperature in order to remove desired moisture and utilize the power. This is the overall hybrid type dehumidifier where it condenses moisture at cooler followed by moisture removal in desiccant. We started calculate from the inlet which passes through the compressor type first, which is cooler. Here are the list of equation used and the basis is 200 kg per hour air. The moisture content in stream 2 based on specified performance is 0.016. Based on psychrometric chart, TCR is 15 degrees Celsius where it is on the dew point curve collinear with the point 1 and XC is obtained using equation 3. Since point 1, 2 and TCR is collinear, equation 4 can be utilized to obtain temperature at stream 2. Here is the psychrometric chart for stream 1 and 2 where point 1, 2 and TCR is collinear. Next is the desiccant type where stream 2 is the inlet. From previous calculation, we already know T2 and it can be used to calculate enthalpy using equation 6 with X2 0.016. And enthalpy change in heat exchanger is also specified where we can get enthalpy for stream 3. There are no moisture removal from stream 2 to stream 3, hence X2 is equal to X3, so it can be used to calculate P3 as we have X3 and H3. H3 and H4 is the same since desiccant works in S enthalpic, so no transfer of heat. So we can use H3 and X4, which is specified 0.014, to obtain T4. This is a psychrometric chart of the second type, which is stream 2, 3, and 4. As for the internal loop air, it has been specified the moisture content at stream 6 and 8, as well as temperature 6, which is 32 degrees Celsius. Stream 8 and stream 6 of condensation process are collinear with point TCD, which is equal to T2 since stream 2 is used to cooling in order to condensate stream 8 to remove moisture after regeneration. Hence, equation 7 is used to obtain T8. Then H6 and H8 can be obtained using equation 6. H8 is equal to H7 due to isenthalpic process, so it can be used in equation 6 to obtain T7, where X7 is also equal to X6. Equation 5 is used to calculate the flow rate of internal loop air to balance energy in order to get desired performance. This is a psychrometric chart for internal loop in desiccant type. Lastly, we can see the overview of compressor type dehumidifier and calculate the enthalpy in refrigerant. T5, which is 35 degrees Celsius, is used to calculate HR1 and HR2 since it passes through the heat releaser. HR2 is equal to HR3 since we assume the expansion valve is isenthalpic. For HR4, the SCR is used since it passes through cooler. Then, the flow rate of refrigerant can be obtained by using equation 9 energy balance. Here you can see the psychrometric chart for stream 4 to stream 5. This is the total power utilized, which is 400.97 watts, which is lesser than 500 watts using equation 8 and 12. And this is the overall psychrometric chart for this type of dehumidifier.
Now, let's move on to the 3D drawing design of our dehumidifier together with its dimensions. We will be looking at each individual component in our dehumidifier where we have our HEPA filter, condenser, desiccant wheel, and heat exchanger. Moving on, we have the heat releaser, heater, and compressor in our dehumidifier. On the outer section, we have 4 tires with locks and a 25-pint tank which will be used to store the water. Overall, this is the final design of our dehumidifier. It is available in 3 colors, which is black, blue, and white, as these colors are universal and appropriate with any room color. The material used for the outer part of the dehumidifier is heavy-duty plastic, as it is an insulator. The components inside our product are made of stainless steel wrapped in black foam to avoid corrosion and increase their efficiency. The tubing is also made of plastic, and we opted for calcium chloride as opposed to silica gel as our desiccant due to its higher performance. It also produces less carbon footprints, and only a small amount of calcium chloride is needed to remove moisture in the air compared to silica gel, where it needs 10 times more the amount to have the same performance as calcium chloride.
Next, for the economic analysis, we assume a 20% discount rate for a 3 years financial projection, and we predict the 30,000 unit of home dehumidifier will be sold annually. This table shows the cost involved in the production of home dehumidifier. The annual sale, we targeted 30,000 unit of home dehumidifier. The price we set at 550 ringgit per unit, and the annual advertising budget is 1.5 million. Manufacturing equipment cost 2.5 billion. Development cost 2 million. Development time is 1 year. And the net working capital is 2.5 million. Fixed cost 2.5 million per year. Variable cost 100 ringgit per unit, and the bank interest is 4%, and the tax 30%. In order to check whether the project can be continued or not, we have to calculate the net present value and the internal rate of return. By doing the calculation, we notice that the NPV and IRR is in positive value, so the project can be continued. Next, this graph is the cumulative cash flow as a function of time. As you can see, 200,000 is spent during the product development period. 5.5 million is used for working capital and purchase of equipment to start up production of home dehumidifiers. Negative cumulative project cash flow of 7.5 million. After the year 0, the cash flow become positive as the profit of selling home dehumidifiers started to generate from year 1.
When it comes to sustainability, there are 3 factors to be considered, which are environmental, social, and economic. As discussed previously, we know that using calcium chloride will result in lesser carbon footprint. The material used in designing our product does not harm the environment, and our product has low energy consumption. From a social point of view, its long lifespan, own refrigeration system, and ease and safety of handling the product means that it will not require much maintenance, and the excellent performance of our product means that it can severely reduce any health risk as well. Economically, our dehumidifier has low maintenance costs and low electricity costs due to the product performance, and calcium chloride is also much cheaper compared to silica gel, so the cost of the desiccant is reduced as well. Whenever we discuss sustainability, it is impossible to overlook the 17 Sustainable Development Goals developed by the United Nations. For our product, it adopts 3 goals, which is SDG 12, Responsible Consumption and Production, SDG 3, Good Health and Well-being, and SDG 13, which is Climate Action. Thus, we believe our dehumidifier complies with the standards expected by AMM and can be sold to customers. In conclusion, our startup company has successfully proposed the design of a hybrid type home dehumidifier which consumes only 400 watt of power as opposed to the average power of 500 watt and has an IRR of 64.6%, which is higher than the bank interest rate of 4%, which can be a benchmark for investors to gain more confidence in investing their money towards our business. Here are also the list of references. So that will be all from our group. Thank you.